All right. So this time, we are going to start using our draw function because we are going to start talking about movement and animation. So fundamentally, we want to start getting into interactivity, right? So something that's time-based, right? So interactivity, by definition, something happens, then something happens again. You click a button, the system responds. So there is always a time component to it. So we always want to start thinking about the time component. So let's think about movement and time animation, right? So let's look at how animation works in P5.js, right? So I think in the very beginning we talked about, so like one fundamental thing is that the setup function runs once in the beginning and it creates your composition, sets your variables to certain values, and does whatever else needs to be done. And then the draw function will run however many frames per second your screen allows. So most likely it's going to be 60 frames per second, maybe 30, maybe 144, depending on your screen. And also depending on your graphic system and your processor and some other technical limitations. But generally, we can say that it's going to be somewhere around 60 frames per second, right? And so an important thing is going to run over and over and over and over and over again, right? Just like a movie reel, right? So let's start thinking about how we can create some movement out of that. So let's go back to our standard canvas size, something that we've done before. Let's do 800 by 600, right? And then let's just draw a circle in the beginning. So we're going to draw a circle, and we are going to put that circle width divided by 2, height divided by 2, and then let's give it some diameter. In fact, let's go back to our previous video and introduce a variable, right? So let's say let diameter equal to, I don't know, 60, something like this. That's fine. So we're going to have a diameter, and then we can also start defining some other components. So for example, diameter is going to go here, but then we also can use a color for that circle, right? So do fill and then add the color in there, and we can predefine some of the colors. So maybe I want the circle to be uh, red or yellow or something yellow. Okay, so let's introduce yellow color, right? So this is going to be a variable. It's not declared right now. In the very beginning, it has nothing. So if you remember, color mode, like blend modes and color modes and all that stuff, is only available to us after we create the canvas. So we can create the variable at the very top, but we're going to define it, right? After our canvas is created. So we're going to say yellow is, right? And we're going to put a color definition in there. That's something that you can also do in P5, right? So you can define your color. So if you go and look at color function, right, it creates a P5 color object. What does that mean? That means that I can say my variable is going to be a certain set of values, and then I can use it inside the fill. I can just basically store my color inside my variable, right? So this is what I'm trying to do. My yellow is going to be a color, and since by default I'm working in RGB, and we can stay in RGB for this particular video, I'm going to do something like, so reasonably large on the red value and reasonably large on the green value because it's going to be yellow, and maybe a little smaller on the blue value. And then I can say yellow like this. And let's do no stroke. No stroke, right? So it's going to be no stroke. So if I run it, I just have a yellow circle in the middle of my nondescript canvas. And nothing is changing, even though I put it in the draw. Nothing is changing because we're not making it change. Everything is always the same. So you will you can almost imagine that it's just a whole bunch of yellow circles being drawn on top of one another, right? So just 60 times a second just keeps drawing yellow circles. Okay, so in order for it to change, we need to start introducing some variations. So if I wanted to move, I'm gonna need to introduce variations in that area. Let's call it that way. And the reason why I'm saying in that area is because I want you to go back to middle school, to your middle school physics, and think about what are the parameters that you need in order to describe movement. What are the sort of like the key things that would describe movement? There are 3 of them, right? And so if you want to pause and sort of ponder and think about what the parameters are, go ahead. If you want the easy answer, I'm going to tell you. The parameters are position, velocity, and acceleration, right? So acceleration will change velocity, velocity will change the position will then move your object one way or another, right? So we are gonna acceleration, right? It's the change in velocity, basically something speeding up and slowing down. Introduces a bit of complication, so let's just kind of like have movement at a constant rate. Everything is position is changing, so there is a velocity, but that velocity is constant, right? We'll come back to the idea of acceleration. It's a very interesting idea and kind of will help us make things move a little bit more naturally. But for now, let's just assume acceleration at 0, nothing changes, but we're gonna have velocity and we're gonna have position. So let's start introducing those. So the position, if you remember from a previous video, we are going to be defining as position in both x and y components, right? So the position of my circle is going to be position x, position y, right? So let's make them the same, position y. And then I'm going to have changes to position x, and I'm going to have changes to position y, which will come from velocity x and velocity y. Let's again make them the same. I don't know. I don't like how the capitals look. Let's do position, velocity, and velocity. Gonna be pedantic over here. All right. So we have position, velocity. We have diameter. So let's set up our initial position in the setup function. So this is going to be our starting point, right? So we're gonna say that our position x is equal to width divided by 2, and our position y is equal to naturally height divided by 2. Okay, so let's do this, and then position x and position y. So here nothing is fundamentally different because we're not changing the position yet, but the position is changed by velocity. So let's introduce a velocity and make the velocity affect the position. So let's do velocity x, and velocity x can be fairly small, right? So let's do, remember randomness? Let's do random number. Let's do random number. It's going to be a random number between -5 and 5. So here's the reason why I'm introducing the minus number. Remember that last time we talked about every time you add something, if you want to move to the right, you want to add something. If you want to move to the left, you want to subtract, right? So if my velocity is going to be pushing my object to the right, I want it to be positive. If I want it to be pushing it to the left, I want it to be negative, right? So basically, whether velocity is positive or negative gives it the direction, right? So velocity is speed that has a direction. So speed will be 5, but it's going to be either +5 or -5. And depending on whether it's positive or negative, it's going to be a certain direction. And then similarly for the y, right? So I'm going to have velocity y, and it's going to be, again, a random number. And that's going to be, let's do it between minus 3.5 and 3.5. The reason why I'm doing a smaller number is because obviously on the vertical axis, I have fewer pixels, right? Only 600. So I'm going to make it a little bit slower. And again, the negative velocity is going to push it up. I know it's a little counterintuitive, but if you remember, our 0 on the y-axis is at the top and our full height is on the bottom, right? So our negative number is going to be pushing it up towards 0, and our positive number is going to be increasing the position y towards the bottom, therefore, right? So if I'm gonna then do something like this, so my position x is going to be equal to itself plus velocity x, and position y is going to be equal to itself plus velocity y, right? So here's what I'm doing. So in the draw function, I'm going to say draw a circle, right, with a yellow fill at this position and with this diameter, and then change the position. Make it itself plus the x velocity for the x position, and itself plus the y velocity for the y position. And now we're done with this draw, and we're going to move on to the next iteration of draw and do it again, but now draw the circle in the new position, right? So if I run it like that, you can see that I start drawing those circles, and they're drawing on top of one another, right? So if I kind of undo this no stroke, you will see it a little bit more clearly, right? So it just draws a whole bunch of circles on top of other circles, right? So for every frame, there's a new circle drawn, so it looks like it just keeps going down. So how do we prevent this from happening? Well, this is where background comes very, very handy, right? So the background will kind of put the cover on top of all the other previous frames. But this time we, instead of drawing the background in the setup, because if you do that, you're only going to draw it once. You need to move the background in the draw, right? So if I put the background, say here, and let's draw like a nice gray background. In fact, let's introduce the color. So let's do gray, and then we're going to have another color, gray, and that's going to be color, right? And let's do some like nice dark gray. So 88, 85, 90-ish, something like that, right? So if I'm gonna say background gray in the setup, I'm gonna get a gray background, but only once, right? I still have all those circles drawn on top of it. But now if I take this line, right, and draw it in the beginning of my draw function, right? So every time I draw the next frame, I draw the background first. Okay, I have a moving circle. Let's try it again. Let's try it again. Let's try it again. This time it's moving a little bit slower. So this way, I basically create this like sleight of hand where all those previous frames are overdrawn, and I am creating a circle moving. Cool. So now we need to, it'd be nice to constrain that circle, right? So it's, if you notice, it's very quickly moving off the screen, right? Because its position keeps growing or decreasing depending on which way it's going. And then very quickly it exceeds the width or exceeds my 0 point. So here's what I need to do. I need to kind of say, all right, so if, and this is where maybe I'll draw this out. So here's my, whoa. So this is my sketch, right? And then I am going to have my circle in here, right? So let's make it a little bit smaller. Let's make it also a little bit more proportional. Actually, I'll just draw with with a pen. All right, so I start right here, right? And then I'll just keep moving and keep moving and keep moving and keep moving. And so this is my 0 point, and this is my width, and this is my 0 point, and this is my height, right? So I need to say that basically whenever we touch this point, we need to start moving, but we need to start changing direction. So if I was going this way, I need to start going that way. And then if I hit the bottom, right, I need to change now the direction on the y-axis, right? So instead of changing from right to left, I need to change from down to up, right? So I need to start moving this way. And so I'm going to move this way and hit the edge and hit the edge and hit the edge. So basically I need to define those edges and say every time you hit the edge, whether it's on the 0 point or the width, or on the 0 point or the height, change the corresponding velocity, right? So we already talked about this idea that velocity is essentially speed in a certain direction. So if we're moving here, it might be 5, right? Because we're moving to the right from 0 to width, that's 5. And then if we're moving backward, it might be -5 or something like that, right? Doesn't matter what the number is. And then again, if we're going down, it might be +3. And if we're going up, it might be -3, right? So I don't necessarily need to change how the speed component of my velocity. I just need to change its direction, right? So flip it from negative to positive, from positive to negative, and so on and so forth, right? So this is a fairly simple operation. Hopefully you remember that from middle school math, right? If you want to change the number from negative to positive or from positive to negative without affecting its value, what do we need to do? Think about it. In the meantime, I'm going to start defining my constraints. So I need to say something like this. If we reach, so let's just take an example, right? So we're okay, so we are going, okay, so this is the example. We were going towards the right, and then we were supposed to hit our edge on the width, right? So that's how I would define it. If position X of my circle is hitting the width, which means it's either the same as the width, as the right edge of my canvas, or maybe even already a little greater. So I'm going to say if it's greater or equal to the width, but we just the same need to catch the other edge, right? So this is our right edge, the width, but our left edge is the 0. And in the 0, it's going to be the opposite direction. So let's see. Can we get it? Oh, randomness. Let me just comment this out. Okay, so here I would be catching it on the left edge, right? So on the left edge, come on, there we go. So here on the left edge, I'm looking for 0 and the numbers are decreasing. So I need to say if the position X is less or equal to 0, right? So in both cases, so this is or, this is that key above your enter key. So if my position X is greater or equal to width, or, right, it's that sign, 2 horizontal slashes, or position X is less or equal to 0, right, I need to do something. I need to flip my velocity from positive to negative, from negative to positive. If you thought about how to do that, if you remembered how it's done, congratulations. If not, I'm going to reveal it. You just multiply it by -1. So 5 times -1 is -5, and -5 times -1 is 5, right? So our velocity X is going to be equal to itself, right? So velocity X times -1, right? Let's space it out just for clarity. And there we go. And we now need to do the same thing on the other side. So if our position y is, so we want to catch it on the bottom where the height is. So if it's greater or equal to height, or our position y is less or equal to 0, again, we need to do the same thing. We need to say, we need to say velocity y is equal to itself, so velocity y times -1. Okay, don't need semicolons in JavaScript. So let's see how that works. Okay, we're moving. Boom, boom. All right, so almost there, right? So it's bouncing, it's changing the direction. The only problem is that it's bouncing off of its center, because that's where the position is defined. So whenever I'm checking for whether the position is greater than width or the position is less than 0, it's checking against its center. So we essentially, what we need to do, we need to say something like this, right? So going back to our drawing board, and let's just erase everything. I'm just gonna take all that, erase it, and then, so if I were to, okay, let's go here. So here's my sketch. So when I am reaching the edge with my circle, so let's imagine this is my circle, I am reaching the edge, I need to say, all right, so here's the center of my circle. If I'm going to be measuring from the edge, I need to either subtract its radius, so half of its diameter, from the width, or otherwise I need to add half of its diameter, or its radius, to its center, right, to its position x. And which way you want to place that number doesn't really matter, right? So similarly, on the other side, if I'm going to be touching this edge, I'm going to be either adding half of its diameter to 0, or I'm going to be subtracting from its position y. So which way you go with this is entirely up to you. I tend to work off of the center, right? It kind of like, it feels better just conceptually to me that the circle will be checking against its own edge, rather than the edge of the screen would be checking for the center of the circle, right? But then again, it's neither here nor there. You can do it any way you like. So so here's what I'm going to say. I'm going to say if position x plus diameter times 0.5, right? So half of the diameter is greater than width, or since I'm moving to the right, I'm going to be adding the diameter or the radius, or half of the diameter, or let's add the 0. Let's be neat about this. If I'm moving towards 0, I'm going to be subtracting half of the diameter. And again, for the y, if I'm moving towards height, I'm going to be adding half of the diameter. If I'm moving towards 0, I'm going to be subtracting half of the diameter, right? Because I'm either checking for the left edge or for the right edge, or I'm checking for the top edge or for the bottom edge, right? And if I run it like that, and maybe it's a little bit faster, boom, boom. Now I'll have it going off of the edges. Okay, so you can also kind of introduce some changes. So for example, you don't necessarily have to calculate the position after you check for it. You can do it before, right? It has more to do with sort of the way you want to describe your world, right? So do you want to first have the velocity affect the position and then check for whether that position is in the right place or not? Or if you want to do it after the check, so only if it passes the checks, you will be adding. It's kind of up to you. This is where like the creativity starts, where there's more than one way of doing things, and you can sort of, as your code is growing in complexity, some of these choices will have some maybe unexpected implications. So ponder, right, which way you want to go with it. But one thing that I wanted to also, like on a very technical level, I wanted to show you is that one way to write this statement would be position x is equal to itself plus velocity x, right? So maybe like let's just space it out. Or you can use a shorthand. Just like with plus plus, we saw the plus plus shorthand, we can also do the shorthand for something like this, where if position y is itself plus velocity, we can say that it's just position x plus equals velocity, right? So these two statements are equivalent, right? So I'm going to leave one of them like this and the other one like that, just so that you had an illustration. And I'm going to space out these statements because I don't like the way they look I'm quite pedantic that way. But fundamentally, this is the basics of the movement. See if you can introduce something interesting, some interesting elements to the movement, and try to try to do something with it. But now you know how the DVD screensavers were created. Very simple. All right. See you next time. Have fun with it.